Okay, YouTube, in my previous video we had introduced the concept of an exponential function, and when I did that I kind of introduced it as this format of y equals b to the x, but by the end of the video we had introduced this other value. We say a times b to the x, where b was the base of our exponent here and our growth factor there, but we say a, this number out front, directly kind of influenced our y-intercept. Okay, so when we looked at these graphs here, we said we had graphs in general that had horizontal asymptotes on the x-axis. So we say that the line y equals 0 is our horizontal asymptote, and we said it went through as 0 comma a, where a was our, like we said here, it was our y-intercept, and then it would just grow exponentially, where that would be speeding up upon itself there, but always going left, approaching a height of 0, never quite getting there. We say that graphs of the form y equals a times b to the x is an exponential growth function if a is greater than 0, so that is the value up front is bigger than 0, and b is greater than 1. That is, it's not or a proper fraction. Okay, it's always going to be an improper fraction, or at least 1. Okay. Or at least, no, we don't even include 1. We wouldn't want to include 1 to the x. Okay, so since we know the basic shape of these graphs now, all I want to do in this video is kind of throw together a couple of really quick graphs and how you might approach that. So let's go ahead and start with this one here. We say y equals 1/2 times 3 to the x. The first thing I want to do is identify a few things here. We say a equals 1/2, and our b value here, our b value is 3. So we have our coefficient out front and our base value on our graph. So looking at this, we would say that the first thing I want to do is kind of find a couple points on my graph. And we usually just plug in 0 and 1. You can certainly make a t-chart here if you'd like. I've got mine listed as ordered pairs. But if we plug in 0, we would obtain a value of y equals 1/2 times 3 to the 0. So again, we get 1/2 times 1, but anything times 1 is itself. So that is to say, whenever we plug in 0, you're always going to get this value out front here as its value if there are no other loose terms attached to this. So we'd say 1/2 is our intercept there. And then we say, okay, well, if I plugged in 1, we say y equals 1/2 times 3 to the 1. I would get 3/2 for an answer, so 1.5 essentially. So to make this graph, we're going to say plot the 2 points that we just found here. So we say 0, 1/2, and 1, 1.5. So 0, 1/2 would be about right here. 1, 1.5 would be about right here. And then I say, okay, since a is greater than 0, now this is important to note here. We say that this was positive. It means that our graph is going to be growth, but above the x-axis for positive y values, okay? So we're going to start from left to right, a line that begins just above the x-axis, okay, and passes through the 2 points and moves up and to the right. So here is our exponential growth curve, and these couple of points right here, it is always appropriate to label those. So we say 0, 1/2, and we say that this would be 1, 3/2, and then we just know the basic shape from there. Also very appropriate to sketch in on your picture is this line y equals 0 in this case, but our horizontal asymptote. Okay, so let's try this again over here. We say let's graph y equals negative, the base is 1/2 to the x. The thing here is that the negative's out front, so I want to quickly identify that there's a -1 times this, if we want to interpret it that way, and that our a value is -1. I'm going to make a note here that it's negative. And then we say that our b value here, our b value is the base of the exponent, is 1/2. Okay. So now, it's a little bit different here when you have a base that is 1/2, okay? So let's talk about y. Let's go ahead and plug in a couple of points here. We'll plug in 0. So I would say that y equals -1 times 1/2 to the 0, where 1/2 to the 0 is 1, so we get -1 when I plug in that. Or in other words, I just get the a value. And then we say, okay, I'll fix that. -1. It's the a value. Okay, so 1. Plug in 1. If I put a 1 right here, I'm going to kind of scratch that out and put a 1. I get 1/2 to the 1 times the -1 is -1/2. Okay, so I get a negative output here. So when I put these on my graph, I say, well, 0, -1 is just right here is my y-intercept because this was -1. And then I say, okay, well, this is at a height of 1/2. You notice that your graph actually decreased a little bit here. So the interesting thing is, if I were to take 1/2 times 1/2 times 1/2 times 1/2, like times times 1/2, and I had x factors of this because I'm raising 1/2 to the power of something, we would be getting a number that is actually getting smaller and smaller and smaller and smaller and smaller. So for the first time, we are seeing a growth function where b is less than 1, but it's greater than 0. That is to say, it's positive, but it's a proper fraction. And whenever we have a proper fraction for a base, we actually have a function that's not going to grow, but that's actually going to do what we call decay. So this is as we go to the right. It is going to approach a height of y equals 0 because, again, no matter how many times I multiply by a half, I'm going to get a number that's bigger than 0. And I would say going to the left here, if I'm dividing by 2 every time I go to the right or multiplying by a half, then going back this way, it would multiply by 2, going down this way. So I could say that -2 and -4 and -8 are actually on this graph here. But we'd say that this is actually what would look like an exponential growth function that's got its orientation turned around, okay? So from left to right, we say that this is a decay function, okay? Decay. So I want to identify one thing here really quickly, but for a function y equals a times b to the x, we say if b is bigger than 1, we say this will be a growth function because we will be taking a number bigger than 1 times itself many times as we go to the right. And if b is less than 1 but greater than 0, then we say that this shall be a decay situation because a proper fraction times itself, x, number of times, is going to produce a number that's smaller than what we started with. Okay, so that's how you throw together quick graphs. You plug in a couple of x values, 0 and 1, plot those points, note where the asymptote would be, and then just kind of give it a good sketch. Cheers.